Once, twice.
Can we go over
Yes.
question that was in the quiz, or one of the quizzes?
At the end of the class, because Ricky has extra time and he's still working on it. Yes. Yeah. Very good. So let's start with 2.5. Continuity. Okay. So let's look at few graphs. Here's the first one. Here's the second one. Here's the third one. And here's the fourth one. Maybe I should add one more. Here it is. First question, would you agree that they are all different? What would you say about the first one? Yes, because I graphed it without lifting my pencil or marker off the paper. It was all smooth, continuous function. Perfect. What about this one? So I will say for now, we don't know much about continuity. We haven't discussed continuity, the point, and so on and so forth. But I will say that this is a continuous function. What do you think about this one? Yes, Ricky, finished?
Yeah. Thank you very much.
Okay, so what would you say about this one? Is it continuous? Obviously it's not. What type of discontinuity is this? Jump. It's a jump discontinuity. Okay, what type of discontinuity? Obviously this is discontinuous. What type of discontinuity will this one be? It's called infinite. Infinite discontinuity. Now these two are the same in the sense that they are both called removable. So removable discontinuity. We'll talk about all of them, especially about the removable in a minute. So let's come back here. Would you agree that this function is continuous as long as it continues at each and every point? If it's continuous at each and every point, it will be continuous on the interval or everywhere in this case. Okay, so now let's discuss, and I'll come back to the other graphs. Continuity at a point. I'm going to choose a point. I'm going to say this is A. And what is this? The y-coordinate? Of course. We have to remember that. For any function, if we have x, the y-coordinate must be f of that x. No question there. Good. So continuity at a point, x equals a. Of course, a comma f of a. But I'm interested in just writing as x equals a for now. Okay, so what has to happen? Is this function continuous at this point?
Yes.
Good. What has to happen? The limit from the left, the limit from the right, and the function value at that point must be, it must exist, it must be the same. That's exactly the definition of continuity at a point. So let's write the limit as x approaches a from the left of f of x. What do I write next? Must equal. Must limit equal the limit of f of x as x approaches a from the right. And must equal, which is, we just wrote it. Exactly. This is the definition of continuity at a point. Definition of continuity at a point. Crucial definition moving forward. So the function to be a function to be continuous at a point, the both limits left and right must exist and be a number, and not any number, but equal to the number that represents f of a. So then, what is continuity on an interval? Continuity on an interval. Or all on all real numbers, which is also an interval. How will you define continuity on an interval? A function is continuous on an interval if a function is continuous on an interval if it is what? A function is continuous on an interval if it is exactly continuous at each and every point on that interval. Of course. Can you name a function that will always be continuous? All polynomial. Excellent. Polynomial functions are always continuous. Can anyone name another function that you know it's continuous on? Polynomial. These are all polynomials. Quadratic, linear. Correct. What about rational functions? Rational functions are continuous everywhere where they are, and I'm missing a word. Rational functions are continuous everywhere where they are, of course, thank you, defined. Absolutely. Same with trig functions. Same with trig functions. Log functions. Is there any other function that you know will be continuous everywhere? How do we call this function? Very good. All exponential functions. Exponential functions are continuous everywhere. What about radical functions? They are continuous where they are defined. So I'm going to add them here, comma, radical. So rational functions are continuous everywhere where they are defined. Same with functions like trig, log, radical. Two other functions that we will see later on, I'm not going to talk about them right now, are hyperbolic functions, as well as inverse trig functions. Okay? And so on and so forth. Enough for now. I'd like to come back to our graphs. This is a jump discontinuity. However, this function is continuous from the left. Why is it continuous from the left? Because the limit, so let me make sure you understand that this is an open point and this is a full point. So this function is continuous from the left. Why? Because the limit from the left and the function value at a are the same. Is this function continuous from the right? No, because the limit from the right and the function value are not the same. So continuous from the left. And I would like to write continuity from the left. And then I'll come back to the rest of the graphs. So continuity from the left. From the left. Limit of f of x as x approaches a from the left equals, anyone can help? Of course. This is continuity from the left. Can anyone tell us how it will look continuity from the right? As x approaches from the right equals? Perfect. Any questions so far? Okay. Yes? Yes, please. Okay, Ricky? Good? Okay. Next graph. This function is not continuous from the left, it's not continuous from the right. This is an infinite discontinuity. Done. What happens here? And why do we call this removable? Why do we call this removable? Here it is why. The limit from the left and the limit from the right, are they the same in both situations? Yes? The limit from the left and the limit from the right, are they the same in both situations? Correct. However, what is the only problem here? It's not the limit from the left and from the right. It's the way the function is defined at that point. That can change. We can change it to create a function that is continuous. That's why this is called removable. I can remove such a discontinuity. I can remove. How? Creating a new function and filling that in. Or moving this point here. So I can do that. But from here, for this function, I could never remove the discontinuity. I could never create another function that will be continuous and have this concept or this initial graph in it. Same thing here. I can never remove this discontinuity. This one and this one I can. What is the condition again for this removable discontinuity? Removable discontinuity. Can anyone tell us what has to happen for a discontinuity to be removable? So I can change it by creating a new function. What has to happen? Exactly. The limit from the left as x approaches a must equal the limit from the right as x approaches a. So this is the condition. So the only problem is the way the function is defined at that point, which we have, in certain situations, we have control over. But we don't have control over the limits left and right. Okay, I like to look at a graph in your book. Bless you. So here it is. So this problem is asking us, it's problem 4 on page 127. On 127. It's asking us to present the intervals on which the function is continuous. All intervals for continuity will be open intervals. However, if the point exists, you could close it. You could put a bracket. Okay? So, is this function continuous between -4 and -2? It's continuous, and it's continuous on the left. It's continuous on the right-hand side of -4, right? Because of the full point, the limit, and the function value. Now, is this function continuous on -2? No. What type of discontinuity is this? It's not removable because both limits left and right are not the same. So this is a jump. Very good. What about this one at 2? A jump. What about this one? Infinity. What about this one? Jump, and so on and so forth. So what will I say the function is continuous on? -4 to -2 with a parenthesis. Union -2 to 2, both parentheses. Union 2 closed to 4, parenthesis, union 4 to 6 with parentheses, and 6 to 8. I will write it down for you right this moment. Any questions on this? Any questions? So for 4 on 127, F continuous on -4, -2, union, -2, 2, union, 2, 4, union, 4, 6, union, 6, 8. Any questions? Yes, please. Vanessa.
Where it says -2 and then 2, why is it a union and then nothing, and then a unit, or union and then 2, 4?
Between -2 and -2?
After that, it's for 2 and 4.
Because the function is continuous every point except at that point, except at 2. So if I put a parenthesis, I'm not including 2.
Yeah, and then there's
But
union.
symbols.
Oh, no. Hold on. Oh, I see. What did I do?
You put 2 union symbols after the -2, 2 neutral, and then 2, 4.
So the -2 to 2, is that where the problem is?
No,
There's 2
it's
unions.
after it.
So there's
After
two unions.
Oh, just to, only because I want you to realize that if I don't write anything, you may think that this is it. You may not look at the next row. I'm not using 2 unions. I'm telling you something else follows, but I don't have room here. You can disregard one of them. Okay? Yes, please, Vanessa.
So is it discontinuous? So
It is discontinuous at 2.
which 2?
So on this side, it's discontinuous.
Okay.
On this side, it's continuous from the right.
So if it's a bracket, it's continuous. If it's
Continuous from the right. Maybe I shouldn't write it like that because it's possibly confusing. Maybe I should just write them without the union at all. Maybe that's better. I think you have a point.
I'm not worried about the union.
I am worried about the unit because when I put -2 to 2, union 2 to 4, then it should be understood that it's continuous between -2 and 4. Would that be, and that would be incorrect. So I think it's better if I omit the unions completely. I think it's a very good point. So I'm going to do that. So please omit the unions, just put a comma. Not to be understood that, because that's the confusion now, and I see it. -2 to union 2 to 4 really means -2, 4. And that's not what I wanted. Okay? So I'm going to simply put commas.
So if you put commas on the put test, is okay?
Yes. Yes.
So what is the difference between the brackets and the parentheses?
It's including. It's a full point.
Okay.
The bracket, it's a full point. Parentheses, it's an open point. Yes,
So the-
exactly how we did with
Piecewise.
piecewise defined functions. Correct.
So if it's a bracket, it is
It's continuous from the right.
from the right.
Yes.
And if it's a parentheses, it's discontinuous.
Correct. Yes, it's discontinuous.
In general.
Yes, at that point. Yes. Yes. Very good. Good point. Any questions on this? Any questions? Let's look at page 129. I would like to look on or work on a problem like 46. On 120, one more time, 129. Any questions, please? Anything? Any questions? Okay. So f of x is a piecewise defined function, x squared minus 4, divided by x minus 2, and ax squared minus bx plus 3, and 2x minus a plus b. And the first one is when x is less than 2. The next one is from 2 close to 2, less than 3, and greater than or equal to 3. It looks like a very complicated situation. Here's the question. Find the values of a and b that make this function continuous everywhere. So how many variables we have? Good. So there are two variables in this problem. Here there's nothing. A here and a B here and A here and a B here. So I want to make this function continuous everywhere. First, let's analyze the x squared minus 4 over x minus 2. What will you say about that? Exactly. So we are discussing just this piece for a moment. And yes, we will factor the top. How do we factor the top? And now I would like to simplify by x minus 2. But before I simplify, I have to make sure that x does not equal 2. But it doesn't. I'm safe, right? I don't have to exclude anything. This specifically says x less than 2, so I'm okay. So then the first branch of the function can be simplified into x plus 2. I will rewrite the function because this is very important. Remember, my first thought ever is what? Simplify and factor. Simplify and factor. Okay. So the function now becomes x plus 2 for x less than 2. And the other two branches do not change. Ax squared minus bx plus 3 less than 3. And then 2x minus a plus b greater than or equal to 3. Okay. Yes.
So at the top one,
Yes.
what equals x plus 2? You didn't really write what
This
that equals.
equals this equals this.
Okay, so that top one is equal to x plus 2.
I simplified x minus 2 by x minus 2, x minus 2 by x minus 2, and the simplified form of this equals here.
Okay.
That's the reason why, and I know maybe this is kind of unusual, that's why I put the equal symbol so you know something follows. Otherwise, you may not connect the next step. Is that clear? Perfect. So now, can anyone tell us what type of functions are these? This function, and this function. Good. I will say, number 1, all pieces are continuous on their domain, on each domain. Or you can say x plus 2 is continuous here, this other second branch is continuous here, third branch is continuous here, as polynomial functions. Step number 2. For this function to be continuous everywhere, what do I have to worry about? Continuity at 2 points. That's what you're saying. Which points? Exactly. So I'm going to study now continuity at 2. Later on, step 3, I will study what? Good. So please dictate the definition of continuity for the continuity at 2. What do I have to write? Very good. As x approaches from the which part? Excellent. We have to make it equal. Limit as x approaches from the right, from which branch? Ax squared minus bx plus 3. And it must equal, yes, f of 2. Excellent. Do we all understand this? Yes, Vanessa?
I'm not too worried about the first one. Where's the limit?
Limit from x approaches 2 from the left, 2 from the right.
Are they all like linked together? Like
It's one function.
Okay.
It's a piecewise defined function. It's just one function.
Okay.
With 3 different branches, but only one function. Good. So can anyone give us the number for this left-hand side? Of course. Can anyone give us the number or the expression for the middle one?
64
Careful. 4a minus 2b. Very good. Can anyone give us this? And tell me which branch will you use? Top or middle? Middle, of course, where the equal symbol is. I just have to copy this. I don't have to repeat it. I'm going to say same. So can anyone give us the first condition that this function or the a and b have to fulfill for the function to be continuous? I want to write the equation and box it in. What has to happen for the function then to be continuous at x equals 2? What will you tell me to write? 4a minus 2b plus 3 equals 4. This is our first equation, number A. Do we understand? We all understand how we got this. Any questions? Is this clear? Yes.
Why did you put equal sign?
So for a function to be continuous at x equals 2, the limit from the left must equal the limit from the right, must equal the function value at 2. So therefore, this number must equal this number, must equal this number. And that's how we get the first equation. Any questions? Is this okay?
So you move it to the other side to equal it, or does it not matter?
I prefer variables on the left-hand side. It doesn't matter. 4 equals 4 is 4 equals 4. Right? It doesn't matter. Otherwise, the function will not be continuous at that point. Yes?
How do we know the limit from the right and the function value are the same?
We want to make it the same to find a and b that makes it the same. We want to make sure that the function will be continuous everywhere. So we have to impose the condition that the limit from the left must equal the limit from the right and must equal the function value at that point.
So for the function value of 2, how do we know it's the same as the 4?
Because we use this branch from the right and its equal symbol. And I have to plug in this. I cannot plug in that. There is no equal symbol for 2. So the equal symbol for 2 is here, so I have to plug it in here. So that's why these two must be the same. Is that okay, everyone? Yes? Are you with me? Other questions? Yes, Vanessa?
So is that just how we leave it? With that, do we have to like?
We have 2 variables. We only have 1 equation.
Okay.
We're not there yet. Okay, very good. Continuity at 3. Can anyone dictate, please? As x approaches 3 from the left, which branch? I don't want to write it twice, that's why. The middle one, very good. Must equal. Limit as x approaches 3 from the right. From which branch? Very good, awesome. 2x minus a plus b must equal f of 3. Good. Can anyone give us the left-hand side? What does this equal to? 9a minus
3b.
Very good, awesome. Plus 3, good. Can anyone give us the middle part?
6 minus 8 plus b.
Excellent. Can anyone give us f of 3 and you tell me which branch you use for f of 3? Bottom one. So it's going to be the same in this case. So now we have a second equation. Can anyone dictate the new equation that we will have to pair with A?
9a
Yes?
minus 3b
Yes?
plus 3
Yes?
equals 6 minus a plus b.
This is our equation B. So we obtain an equation A with 2 variables. We'll obtain an equation B with 2 variables. Now, what do you think we're going to do with these 2 equations? Yes, create a system. Our past algebra. System of 2 linear equations. I want to simplify the first equation by moving 3 to the other side. Can anyone give us the first equation, please? 4a minus 2b equals? Excellent. Very good. In the same way, I want to simplify the second one. I would like to add the a. I would like to subtract the b and subtract the 6. I want to write the second equation fully simplified. 10a indeed. So this goes next to 9. Good. Minus 4b, excellent, because b is subtracted from both sides. Equals? Equals 3. Excellent. For such a system, we have at least 2 different methods. I'm thinking of elimination. Which variable would you like to eliminate? Exactly. Why B and not A? Because it's easier. And I will multiply the first equation both sides by? Of course, excellent. By negative 2. Negative 8a plus 4b equals negative 2. 10a minus 4b equals 3. Excellent. Multiplying both sides of the first equation by negative 2 created the positive 4b and the negative 4b that I have from the other two, from the second equation, and then those two will go away. Excellent. So this is 2a equals 1. Well done. So how much is a? 1/2. Now we have to go back anywhere. It doesn't matter where. Either the first equation or the second one. Insert, yes, excellent. And get b. So I have 4 times 1/2. I'm going back to the first equation. Minus 2b equals 1. Simplify. 2 minus 2b equals 1. Negative 2b equals negative 1. And b equals 1/2. Nice. I have to write the new function. Go back to the original. X less than 2, 2, 3, and green equal to 3. Yes, please. I divided both sides by 2. Other questions for me, please? Anything else? Okay, so we go back. We have to rewrite. The first branch, there is nothing to insert, just x plus 2. What about the second branch? I will have to write 1/2 x squared minus 1/2 x plus 3. 1/2 x squared minus 1/2 x plus 3. Can anyone dictate the last branch? But a is 1/2, b is 1/2, so
2x minus 1/2.
Plus 1/2.
They cancel.
That's it. What can you say about this function? Guaranteed forever. What? Everywhere. We determine the unique a and b that make this function continuous everywhere. Any questions, first of all, about the procedure? Any questions, please?
So, that first one that we did, the x squared minus 4 over x minus 2, we did that one by itself, basically, and then the last
We simplify the function. We always simplify all functions better. If you give me a function, first I'll simplify it, and then I'll look at what you want me to do.
Okay, and then,
So it's not connected to the procedure.
okay,
I would always simplify and factor. Everything you give me, if it's an equation, if it's a function, if it's whatever you give me, the first thought, I don't even read what you want me to do.
Okay.
Simplify and factor first.
okay, and then after that, basically, we just did the first one, the second one, the second one, the third one, that's what I thought, like, because we did the,
So
simplified it.
so
and
we
then
knew
did-
that all 3 branches were continuous everywhere.
Yeah.
But I wanted the entire function to be continuous everywhere.
Yeah.
The only concern I had was what happens at 2 and what happens at 3. As long as at 2, the limit from the left, the limit from the right, and the function values are the same, it's continuous at 2. At 3, as long as the right limit, the left limit, and the function values are all the same and exist, it's continuous at 3. And I made it continuous by determining the appropriate a and b that make it continuous everywhere. Vicky?
So We got x equals 2 and x equals 3 from x less than 12 and
Say that way.
so we got x equals 2 and
Yes.
x equals 3.
Yeah, because that's the only concern I have. Remember, piecewise defined functions can have a jump there. And I don't want it to have a jump at 2. I don't want it to have a jump at 3.
But then we found the limit for
The limits from the left and from the right helped us determine the correct A and B.
okay. And
Yes.
we use like the elimination method to
Oh, for the
eliminate-
system, yes, we use the elimination method. You can do substitution, but it would be harder because you're gonna have fractions in there. Any questions for me? Yes, please. Robbie?
So in this example,
Yes.
It looks like we almost ignored F2 and F3 because it
No.
was either equal then or less.
No, they were part of the problem. They were part of the problem. I just didn't want to write it through twice.
Right.
Because I cannot write this equals this and this equals it itself again. That
Right.
was the only problem.
Right.
If this equals that, it's the same with this equals this. And these two are the same.
Yeah,
So I have to-
exactly. They're the same.
Yes.
That's what I'm saying. So it almost makes it redundant if you can write it down. So
Uh,
would there be a
no,
situation
because
in which
because the
we would
function
have-
no, because the function may be undefined here. And
Right.
if I write that it does not equal f of 3, then I'll say I will never be able to make this function continuous.
So you would just stop dead in your
The fu-
tracks if
yes.
it was
And that's it. I will say, right, exactly.
Okay.
The continuity at the point has 3 pieces. I have to
Yeah.
show all 3 pieces.
Right.
Limit from the left, limit from the right, and the function value.
Even though the function value is going to be equal to one or the other.
It doesn't matter, I have to show it.
Okay.
Yes, very good question, actually. Yes, please, Vanessa.
Can we do like a similar example?
Yes, we can, but maybe a little bit later, because this is just a long procedure. It's a repeat of the same thing. Limit from the left, limit from the right, and the function value. They're all the same. I don't have another example handy. I need to make one up or find another one that works. I don't have another with 3 branches. We can work on one with 2 branches, like 45. So we can put that behind. So 45 on 129. So the same question. Make this function continuous, f of x, but I can't find another one with 3. And I cannot make one up in 3 seconds. My apologies for that. So this one has only 1 variable. So we're asked to find c that makes this function continuous everywhere. And I have to write as the first step, this is mandatory step, that cx squared plus 2x and x cubed minus cx are always continuous. Always continuous as polynomial functions. I must write this as the first step. Then, what is my concern? Continuity at x equals 2. Excellent. What has to happen at x equals 2 in order to make f of x continuous everywhere?
Both sides would be the same.
Yes, I have to write it though as 3 different pieces. So limit as x approaches 2 from the left, from which branch? Squared plus 2x must equal limit as x approaches 2 from the right, from, I know it's a silly question, x cubed minus cx, and must equal, excellent, very good. So now, can anyone give us the left? Good.
4x plus 4, I mean 4c plus 4.
Can anyone give us the middle?
Yeah, 8
Yes,
minus 2x.
good. Can anyone give us f of 2? You can write it, so I didn't want to confuse you. Let's write it because I wrote the same because I got lazy, but I shouldn't. 8 minus 2c. So now what is the only condition we have to establish? 4c plus 4 must equal? Good. So I move 2c, I get 6c. I move 4, and I get 4. So then C must be 2/3. In the previous problem, we had two variables, we got two conditions, and that's why we had to create a system. So now I have to go back and rewrite the function. So then the function f of x, can anyone dictate? 2/3 x squared.
Plus 2 times 2/3, which is 4/3.
We are only replacing c. We're not changing the function.
Oh,
Good. And then x cubed, 2/3 x. Good. So what can you say about this function forever?
it's
And I meant to write it here also for the previous function. Continuous on negative infinity to infinity, guaranteed.
tell if it's continuous.
No, not before you study this, to study what happens at a point. You have to determine c. You have to write a condition to find c. Otherwise,
And if C is positive, then it's
it doesn't matter. It can be positive or negative. It doesn't matter. C is just a constant. It's called the parameter. So this is continuous on negative infinity to infinity. Agreed? For sure? Any questions? Any questions? Any questions for me here?